this idea of the sandwiched polarizer. And you guys are going to add into your notes sort of this cartoon strip, okay? And I'm going to talk you through how to add it in. And we're going to pause and do this like at a reasonable pace. And don't worry if you miss anything, I'll show it to you afterwards, okay? But I want you to go through the process of actually drawing it. So first of all, we end up in the leftmost cell of your cartoon strip, we're going to have some unpolarized light. And when we talk about unpolarized light, I'm going to ask you to draw this. And what we have on the cartoon strip is just a circle with a dot inside of it. So draw all the different polarizations to the light. And so this is going to represent our electric field that's fluctuating because of a whole bunch of different orientations for photons. So that's cell 1. And the caption underneath of this, it's already provided for you, is that this is unpolarized light. So this is light flying at your face. In the next cell, you have a circle that has vertical lines. And of course, if you have a circle with vertical lines, what orientation is the light going to be when it comes through? Vertically polarized, right? Right? You look at the caption, it says polarizing filter allows only the orientation of light aligned with the filter through. Okay, so here we go. And so what I'm going to ask you to do is I'm going to ask you to add in this orientation of light into that second cell. We have just the vertically oriented light, and so you're going to draw that superimposed on top of your picture. Only the vertically oriented light is going to be allowed to get through. Remember, this is light that's traveling at you. Sorry, I'll go back. This is light that's traveling at your face, and this is the orientation of the light wave. That's what this double-ended arrow is representing. The orientation of the electric field wave. Now the next cell over is actually blank on your page, but what I'm going to ask you to do is add in horizontally polarized filter. So here it is up on the screen, the whole horizontally polarized filter. And the caption says, a second polarizer rotated at 90 degrees to the first one is added in series after the first. And so how much light is going to get through this one? 0. Answer is 0. 0 light's going to get through. So I'm going to pause here because no light is going to get through here. So in the fourth cell in your comic strip, can I just ask you to write in big bold letters, blackout? Blackout, okay? And what we mean by that is 0 light intensity gets through the perpendicular polarizer. Now for your second comic strip, again, we're going to start off the same way. We've got unpolarized light flying straight at you. So have all the orientations drawn on there, a whole bunch of different arrows oriented as shown. But in the second comic strip cell, we've got our vertically oriented light. And again, just like in the first comic strip, we have vertically oriented or vertically polarized light coming through that first filter. And the caption reads the same way as it did the first time. Polarizing filter allows only the orientation of light aligned with the filter through. And so by the time we get to the third cell in our comic strip, now we're going to angle our filter. Notice that the angled filter is at an angle relative to the vertically polarized light that strikes its back. And I feel like at this point, I want to see if I can grab my... Oh no, I can't draw on it. That's okay. I don't have that tool set. But as can you guys see where my cursor is going here? My cursor, actually, you know what? Maybe I do want to snap a shot of this. Let's see what it can do. If I steal this picture, I'll just pull it into this software for a second. I don't have a clean other way to do this. If I steal this picture, and I add a little drawing in here, I'm not going to be perfect because I'm freehanding it with a mouse, but can you see that I could construct couple of right angle triangles here. And just like to drive it home, this is a right angle triangle, and this is a right angle triangle. The red line that I tried to draw on an angle here is in line with the filaments of that filter, yeah? What that means is that based on the angle, the relative angle of the new filter compared to the original incident ray, can you see that the hypotenuse, or sorry, the base of this triangle is in line with the original or the new filter, and the blue line is the hypotenuse of these two right angle triangles. And so the amount of electromagnetic field energy that gets through is going to be related to that component that aligns with the new filter. So I wanted to do this quick little sketch because I feel like it's hard to pick up where this next picture comes from unless I do that. So let's just see how it comes out on this page. I got my blue vertically oriented light. I've got my now angled polarizer. And as the light comes out the other side, oh, I guess I wasn't playing. As the light comes out the other side, can you guys see that component of light is now the base for those two right angle triangles that I was trying to sketch earlier? And so if you wanted to complete it and turn it into two right angle triangles, just to help yourself visualize this a little bit, what we're basically saying is that there's a component of that vertical oriented light that's able to get through. It's a component that's related to the right angle triangles that are created, okay? So that if you like, there's a theta relationship where theta is the angle of the polarizer relative to the angle of the original polarized light. Cool? I'm getting like a few head nods. Yes or no? All right. There I am trying to trace out the triangles with my cursor. And of course, the little dialog box underneath says a second angled polarizer, a component of the original light, gets projected through the angled polarizer. Now, of course, if we take this now angled polarized light, it's linear, but it's at an angle. And then we superimpose on top of that a horizontally polarized filter. So I'm going to ask you to add into your fourth cell a horizontal polarizer. So in your fourth comic strip cell, add a fourth polarizer and an angled ray that strikes the fourth polarizer. Sorry, the third polarizer, the fourth cell. Just like the previous cell, a component is going to get through. And so this component I've drawn as yellow. This is going to be the component that actually emerges from that third polarizer. And of course, the caption is a component of the original light gets projected through a horizontal polarizer. I want to take this away. Just back up a little bit here because we've got our comic strip now. Get rid of this guy. And I'd like to pull up my camera and say, this is what we should have right now. You should have a series of diagrams that look something like this, okay? And really what we're showing is the process of, if you wanted to go back and look at that original picture, the process of some light getting through, despite the fact that the original polarizer is vertical, the final polarizer is horizontal, there's an intermediary that's on an angle, okay? So this is just like a quirk, I guess, if you like, but something that I wanted to make sure that we didn't miss. And if you did care about cuttlefish, there's just a little bit more about cuttlefish.